So Ankit this side, and today what I thought is I'm going to start a new series of lectures on a graph theory, and I will cover each and every topic of graph. And what why I am going to start graph? Cause I've seen that in YouTube there are limited content on a graph, and people thought it is a very difficult subject and very difficult data structure, and we can't solve graph problems and all. But believe me, I will start from scratch, and I will cover each and every concept in a graph, but I won't jump directly into a coding, because if you don't know the basics, then how you can build a house if you don't have any map for that house. So my question is simple. Just learn from basics, okay? Because problem is we can't understand problem. The first problem is we seriously we can't understand the graph problem in a proper way, so that we can go for a solution. So that is why I'm telling you that first, learn from a basic. I'm going to cover everything, each and every concept. So let's start. So why graphs? Okay, why graphs? The first reason is simple. uh, because of its uses. Like, it's a fundamental subject in a computer science. It is also used in algorithm, like graph algorithm. We have breadth first searches, we have depth first search, we have many shortest path problems in a graph, and also used in a very vast subjects like mathematics. And if you are computer science student, then computer networks is one of the subject, then compiler design. There are so many subjects, okay, where we can use the graph data structure. Also, you know what, we have we can convert any problem to graph, any problem. So it is mathematical model, okay. We can convert a computational problem to a graph problem, okay. So mathematicians are still doing research, like in Hamiltonian cycles. And the good part is, if you find a good solution for that Hamiltonian cycle, they will offer you $1 million prize. Seriously, I'll tell you that problem too. And the more is Google Maps. You know what, we are using Google Maps and all, but it is a basic application of a graph. Like how Google Map is using graph algorithms or graph models, okay. So as a computer science student, you should know graphs, and you should know in a very well details. So so I am Void Pointer. I'm going to start from basic introduction of a graph. So let's start. First of all, what is a graph? Okay, okay, let's start. A graph is nothing but something like this, okay, something like this structure. Let's say I am drawing some dots, okay. I'm drawing some dots in a plane, in a 2D plane, and these dots are connected by some lines. The dots are connected by some of the lines. That's it. This is the graph, okay. This is the graph. Now you will say that how much dots are there, how much lines are there. You can have many dots, okay. I've drawn 1 2 3 4 5 6 dots I've drawn here, and 1 2 3, these are the lines I've drawn here. Now if you want to make a graph, You need two things. The first is vertices, vertex, you can say dots. Simply I'm saying dots. Okay, these are the terms you should know because I'm I'll tell you all the terms. So the first term is a vertex. 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 Okay, what is vertex? Vertex, you can call it as a dot. This is dot 2. Also you can call it as a node. These are just a term you should know. Vertex is nothing but something like a dot. Okay, now the second thing is we have edges, or you can call it as lines. The edge is just a mathematical term here, or you can call it as a lines. Don't worry, I will cover each and every concept in a very depth. Okay, so these dots you can see here, these dots are connected by some of the lines. These dots are connected by some of the lines, and these lines are called edges. These lines are called edges. These dots are called vertices. Okay, so let's say these vertex can represent anything. Okay, these vertex can represent anything. For example, let's say these are representing some city. Okay, let's say if this is a India map, I can't draw that map properly, but let's say we have some map. Okay, this is Uttarakhand, this is Rajasthan and Delhi, and let's say one of the south state which is Karnataka. So let's say these are some dots, and these dots, this time I am modeling a problem that these dots are nothing but the city of India, cities of India, or state, I can say, not city, state of India. Okay, this time these dots are representing state of India. Now the edge, let's say the edge is nothing but some road. Okay, some road connecting these cities. This is road, one road from Uttarakhand to Rajasthan, and there are so many path, you can say. Okay, this is from Uttarakhand to Karnataka. This structure you have seen here is nothing but just a graph. That's it. That's the definition of a graph in a formal way. Now, this time I represented these vertex as a cities, but you can represent you can also represent these vertex as a computers in your computer lab. Okay, and servers and so on. And these lines are used to connect the vertex. Okay, these lines are used to connect, means this is connecting this a, let's say this is Uttarakhand. Okay, Uttarakhand is connecting by Karnataka using this road. Okay, so this road is nothing but a edge. Simple, just very simple. Okay, now when to connect two vertex, the problem is you can't connect any to any city to any city. There should be some, some relationship between the vertices. Yes, so is there any necessary to connect all the dots? I can connect this to this also. I can connect all dots to all, but is there any necessary to connect all dots? So I'll tell you. So if there exists any relationship between two dots, let's say now this time I'm representing this dot as a uh, let's say this is a boy, and this is a girl. Okay, boy and girl example, you know very well. You will learn more from these kind of example. Okay, now when to connect boy to a girl, when these are in a relationship. Let's say boy is relationship between with girl, so I'm connecting. Simple. If there is no relationship, let's say this is me and this is me, and this boy is my friend. Let's say his name is Aman. Okay, his name is Aman. If Aman and me having some relationship, then only we can connect. So we can connect. Why? Because we are friends. Friends is also a relationship. Okay, friendship is also a relationship. So we are friends. That's why we are connecting. Okay. Now there is no edge or line between me and that girl, cause we don't have any kind of a relationship. So that is why when to connect these dots, when there exists a relationship between two vertices, then only you can connect these lines. Okay, I think it's done. So now don't say that you are the friend of Aman and Aman is a friend of this girl, you are a friend of this girl. Okay, this is transitive relationship, but there is no direct edge. Okay, there is no direct edge. Now I'm going to you know start with the definition of a graph. Definition is nothing, you don't need to write a definition is all. Just I'm writing that some dots. Okay, some dots are connecting some lines. Some dots can be anything, I told you already. Some dots are there, they are in a 2D plane. Some dots are there, or any plane. Why I'm saying 2D? Because there is a page. Some dots are there connecting some lines. You can write this definition to your notebook too. Connecting some lines, this is my own definition, but this is right one. Some lines. Okay, that's it. It is over, graph is over. No, it's just an introduction. Now the most important thing is how graph theory comes into a picture. See, graph is not a computer science subject. I'm telling you, it's a mathematics subject. Okay, so there's some very interesting problem of why graph comes into a picture. So let me start that theory that okay, I'll tell you later that why graph comes into the picture, because it is a seven bridge problem of Konigsberg. So I will tell you this later. Okay, now let me give you a graph definition in a mathematical way. See, here I gave you this definition in very formal ways, because we have some dots connecting these lines are called graph. But if I'm talking about a mathematical way, then I should have talked that this graph G is nothing but containing two things. The first one is your vertices and set of vertices. Set I am calling set cause I'll tell you why. This is a set of vertices. Vertices means set of dots, and these are the set of edges. Let's say I have a set. I have a set. In this set, I have some. I'm giving number this time. I'm not giving any city name. So I have, let's say, four vertices here. Let's say three vertices here, and one. I'm representing these vertices in a plane right now. 1 2 3. Now I told you that when to connect these vertices if there is any relationship. So uh, if I have a vertices V, then can you tell me that how many possibilities are there? So if you do V cross V, you know cross product of a set. I think you know, because it's a very basic. You are doing cross product. So what this will give is a set where we have all the possibilities. Let's say 1 2. Okay, one. First one 2, then 1 3 1 3, then I have 2 1 2 2 2 3 2 1 uh 2 1 2 2 2 2 2 3, and then I have 3 1 3 2 3 3. Should I write all? You know na cross product. Yeah, basically you know. Okay, and edge is nothing but a subset of this V cross V. What is relation? You know relation. Relation is also a subject or subject also a subset of some relation on A. So it's a relation on V. So it's a subset. This edge is a subset of V cross V. So let's say there is I'm according to me it's not there. So there is a relationship between 1 to 2. So we are drawing this line, and there is also relationship is 1 to 3. There is also relationship between 2 and 3. So in edge set, what are the edges I have? I have 1 to 2, and I have 1 to 3, and I have one more which is 2 to 3. Now this is an undirected graph. I am telling you there is no direction. It means you can go from 1 to 2. Also there is a possibility that you can go from 2 to 1, and also 1 to 3 3 to 1 is also possibility. 2 to 3 3 to 2 is also a possibility. That's why I am writing this 1 to 2 as a in a set. Cause set in set order doesn't matter. So 1 to 2 and 2 to 1, this set is also representing 2 to 1. Let's say if I write 2 to 1 also, 2 1, then you will say why you are writing this again and again, because this is a set, and 1 to 2 and 2 to 1 is also a similar. There is a no order. Okay, so edge is nothing but edge is also a set, vertex is also set. This is mathematical definition I am giving you, and this is a subset of V cross V. Now if you know this, uh, can can you give me some example of a problem where you can convert the real world problem into a graph in a graph model? So the first I'm telling you, let's say we have a face nowadays we have Instagram. Okay, Instagram. Instagram is let me talk about Instagram. Okay, Instagram, or I'll tell you Instagram. So in Instagram, let's say you are the person, and you are represented as a dots here, and it is your friend. Also this is your friend, this is another one. Now you follow him. Okay, you follow him. Now if you follow him, then there is a possibility that he follow you back. Okay, if he doesn't follow you back, then I will tell you this is not a undirected graph, then this should be a directed graph. But right now just see. So there is a relationship. Okay, Let's say it is Facebook and you becomes a friend here. So you are A, B, you become friend of each other. Now B and C also are in a relationship. Let's say these are also a friends. Okay. Now what Facebook will do is Facebook will suggest you some mutual friend. Okay. So Facebook will show in your feed, it will show that C is also a friend of B. So could you please send a request to C also? Cause it's your mutual friend. So that's why this comes into a picture that you can make C as a friend or not. So this is a basic application of a graph. Okay. Also, let's say this is one application. Let's say uh, the another one is a Google Map. Okay, the another one is a Google Map. Google Map. The Google Map is not uh, I can say completely on graph algorithm. It has more things on it, but the problem is basically simply we can say it's a graph problem. How? Let's say we have multiple places here. We can represent these places as a vertex. Okay, I'm just telling you then how you can represent a real world problem into a graph problem. These are the vertices. Now let's say this is your source. Let's say you want to go from your home to your office. Your home to your office you want to go. Now there can be multiple paths. Sure, there can be your gully, so many paths from here there. Okay, so many paths are there. So these path or road are nothing but edge. I'm telling you, these are the edge. These are the vertices. Now you want to reach from your home to office, then Google Map will always show you a shortest path. Google Map will always show you a shortest path. Shortest path. This shortest path is nothing but a minimum distance between your home to your office. The minimum distance. Okay. So there can be multiple factors like traffic and all, but I am just telling you that this shortest path is nothing but a minimum. Let's say this is the shortest path and the distance between your home to office is 1 kilometer. Okay. Now how it is showing that, how it is showing you that this is the shortest path? Cause this is here they applied the shortest path algorithm. The algorithm can be anything. Okay. So you are mapping your real world problem into a graph problem, which is a shortest path problem. It's very popular. It's very popular in a graph theory that you have to find a shortest path from a vertices to another vertices, source or destination. Okay. Second, this one is Facebook. This one is a Google Map. Now the computer, let's say, now there can be many, not this one. Sudoku solver is one of them. Let's say Sudoku solver, and there are so many things. Okay. So this is just an introduction to graph. I'll continue this series. Okay. So now the homework of this video is you have to find some of the real world problem which you can map into a graph. If you find some real world problem, then comment down below. I will read all the comments if you have certain examples. And if you like this video, I think if you like, then hit the like button. Also, if you have any doubt, you can directly comment. I will surely reply. And sorry for you know so long because I didn't upload any video on YouTube for some reason. Okay, so it's just started. Yeah, so we'll meet soon. Okay, bye.